Hi, it's me again. Hi, it's me again. I'll be reading part five of a question three. Where did the instructions come from? Come from. Okay, here we go. The machine goes to the DNA, attaches itself, and begins to move along the DNA. As a train might follow a track, it moves a little too fast for you. You see exactly what it is doing, but you can easily see that behind it there are now two complete DNA ropes instead of one. The narrator explains, this is a greatly simplified version of what goes on when DNA is replicated. A group of molecular machines called ENZYMES travel along the DNA, first splitting it in two, then using each strand as a template to make a new complementary strand. We cannot show you all the parts involved, such as a teeny device that runs ahead of the replication machine and snips one side of the DNA so that it can twirl around freely instead of getting wound up too tight. Nor can we show you how the DNA is proofread several times. Errors are detected and corrected to an amazing degree of accuracy. See the diagram on pages 16 and 17. The narrator continues, what we can't show you clearly is the speed. You notice this robot moving at a pretty good clip, didn't you? Well, the actual ENZYME machinery moves along the DNA track at a rate of about 100 rungs or base pairs every second. If the track were the size of a railroad track, this engine would be barreling along at the rate of over 50 miles per hour. In bacteria, these little replication machines can move 10 times faster than that. In the human cell, armies of hundreds of these replication machines go to work at different spots along the DNA track. They copy the entire genome in just 8 hours. See the box, a molecule that can be read and copied on page 20. 1 gram of DNA carries as much information as a trillion CDs could. Reading DNA. The DNA replicating robot trundle off the scene. Another machine appears. It too moves along a stretch of DNA, but more slowly. You see the DNA rope entering one end of this machine and emerging from the other unchanged, but a single strand, a new one, is coming out of a separate opening in the machine like a glowing tail. What is going on? Again, the narrator provides an explanation. DNA's second job is called transcription. The DNA never leaves the safe shelter of the nucleus. So how can the recipes for all the proteins your body is made of ever be read and used? Well, this ENZYME machine finds a spot along the DNA where a gene has been switched on by chemical signals coming in from from outside the cell nucleus. Then this machine uses a molecule called RNA, ribonucleic acid, to make a copy of that gene. RNA looks a lot like a single strand of DNA, but it is different. Its its job is to pick up the is to pick up the information coded in the genes. The RNA gets that information while in the enzyme machine. Then exits the nucleus and heads to one of the ribosomes, where the information will be used to build a protein. As you watch the demonstration, you were filled with wonder. You were deeply impressed by this museum and the ingenuity of those who designed and built its machines. But what if this entire place with all its exhibits could be set in motion, demonstrating all the thousands upon thousands of tasks that go on in the human cell at the same time? What an awe-inspiring spectacle that would be! You realize, though, that all these processes carried out by teeny, complex machines are actually going on right now in your own 100 trillion cells. Your DNA is being read, providing directions to build the hundreds of thousands of different proteins that make up your body, its enzymes, tissues, organs, and so on. Right now, your DNA is being copied and proofread for errors so that a fresh set of directions is there to be read in each new cell. Transcription: how DNA is read. 1. The DNA is unwound here, and exposed strands passes information to the RNA. 2. The RNA reads the DNA, picking up the code within a gene. The DNA code tells the transcription machine where to start and stop. 3. Loaded with information, the RNA exits the cell nucleus and goes to a ribosome, where it will impart the instructions on how to build a complex protein for transcription machine.